So, chemical bonds, what are they? Well, they are most certainly not secret spies working for some top secret spy agency within atoms, or I hope they aren't because that would be odd. They are what hold atoms together to make compounds or molecules. Naturally, most atoms are unstable, so by forming bonds they gain stability. Atoms gain stability by completing their outer shell of electrons, or their valence electron shell. The electrons of each atom are attracted to the protons of the other. The two bonds that we will talk about today are covalent and ionic bonds, not James Bond. Let's say that one day you want to go skiing with your friend. You arrive at the gondola, which can seat up to 8 people inside. The gondola is being filled up, and at the moment there are 6 people inside. The single person next to you doesn't get into the gondola because the gondola still wouldn't be full if only one person was added, and the goal is to fill it up completely. The group of 3 to your side doesn't get into the gondola either because they would have to split up in order to fit 2 of them inside, and they don't want to be separated. So, you and your friend are the ones to get inside the gondola, filling it up completely, and you're on your way to the top of the mountain. This scenario is really similar to one of 2 chemical bonds, ionic bonds. Ionic bonds are when electrons are transferred between atoms, and it occurs when one atom has sufficient strength to remove the electron from the other. In this bond, the electrons are transferred from a metal to a non-metal because electrons can be easily taken away from metals and are attracted to the non-metals. They are formed between ions because the atom that loses electrons becomes a cation, or a positively charged ion. It is not a positively charged cation, and the atom that gains electrons becomes an anion, or a negatively charged ion. In ionic bonds, the atom that loses electrons will become stable because it will have gotten rid of all outer electrons, allowing its next shell to be full and stable. The atom that gains electrons will gain enough to make a full outer shell of valence electrons, allowing it to be stable. One day, you're drawing with your friend. Your friend has a blue marker and you have a red marker. And your friend needs the red marker that you have and you need the blue marker that your friend has. It wouldn't make sense to trade your markers because you'll need your original marker back, so instead, you guys sit next to each other and now each of you has access to both markers. This scenario is similar to the other type of chemical bond, covalent bonds. However, atoms in covalent bonds don't share markers, they share electrons. Covalent bonds are when electrons are shared between atoms, and it occurs when both atoms don't have sufficient energy to completely remove the other atom's electrons. However, there are 2 types of covalent bonds, polar and nonpolar bonds. Polar covalent bonds have atoms with varying electronegativities, or the uneven sharing of electrons. It doesn't mean they're living in the North Pole with polar bears, but they do in fact have varying polarities. This bond is formed between 2 nonmetals or metalloids. The electronegativity of an atom is the strength with which an atom holds shared electrons, which means a more electronegative atom holds on tighter to electrons compared to a less electronegative atom. So, if 2 atoms in a bond have varying electronegativities, the electrons will be more attracted to the atom with a higher electronegativity. The electrons will spend more time around the more electronegative atom and less time around the less electronegative atom. When the electrons are closer to one atom than another, it creates a slight negative charge in that area and a slight positive charge in the other atom. Nonpolar covalent bonds are between 2 atoms that have the same electronegativity, so each atom is pulling equally on shared electrons and the sharing is equal. This bond is between 2 nonmetal or metalloid atoms. Since the pulling force from each atom is identical, it cancels out, and electrons are distributed evenly between the 2 atoms. This is usually the case with 2 identical atoms, like, for example, 2 atoms of hydrogen. However, it can also happen with atoms of different elements if their electronegativities are almost identical, or if 2 atoms of the same element are pulling equally on an atom of another atom in, for example, carbon dioxide. So, how do we count up all of the tiny atoms and bonds? We can't see what the atoms look like and count them up with our eyes, although that would be very impressive. Instead, we use a molecule for covalently bonded atoms and a formula unit for ionic bonds. A molecule is the smallest part in a covalent substance that contains all properties of that substance, and it is the smallest particle that can participate in a chemical reaction. So, carbon dioxide will look something like this as a molecule. A formula unit, on the other hand, is the lowest whole number ratio of ions, or the atoms, in an ionic bond. Since the ions in an ionic bond are arranged in a crystal lattice, They go on basically forever, so we use the formula unit to describe one small portion of the seemingly infinite lattice. So for calcium chloride, the formula unit would look something like this. There's a lot of compounds out there. Some common ones are ethylene, methane, carbon dioxide, ammonia, hydrogen chloride, sucrose, potassium chloride, potassium bromide, and calcium chloride. The ones that we will be looking into today are carbon dioxide, sucrose, and calcium chloride. Carbon dioxide is something everyone knows. It's what humans and animals exhale, and plants take it in to produce oxygen. It is also produced through the combustion of wood, organic materials, and fossil fuels such as coal, peat, petroleum, and natural gas. It is also used to carbonate your soda or to make it bubbly and fizzy. Some fire extinguishers use carbon dioxide to control electrical and oil fires that cannot be put out with water because carbon dioxide is a non-flammable gas. It is a chemical compound composed of 2 oxygen atoms covalently bonded to 1 carbon atom. Sucrose, or table sugar, is what's used to make food taste sweet. Sugar is typically extracted from sugarcane or sugar beet. Early European physicians recommended sugar for the treatment of diseases. Both Buddha and Mohammed suggested its use as a medicine. Good thing we developed better medicine, or else we would be stuck eating sugar every time we got sick. Although, it would be nice to have an extra dose of sugar every once in a while. Due to the varying electronegativities of the atoms in sugar, the electrons are not equally shared in this bond, making it a polar covalent bond. Calcium chloride is something we use every single winter. We know it as snowmelt. It's the most popular type of snowmelt that doesn't contain sodium. It's an exothermic compound, which means it produces heat when mixed with moisture, so when it's in contact with snow, it absorbs the moisture, it heats up, and it melts the snow. Typically, calcium chloride is made when limestone chemically reacts with hydrochloric acid. The calcium gives an electron to 2 chloride atoms, making it an ionic compound. Thanks for watching, and I'll see you guys next time. Bye!